Hello everyone. Today we are doing exam 4, page 2, question 1. For this question, we are supposed to suppose that a particle moves along a curve with acceleration defined by a of t equals 18t minus 4. We must find the equation of position from the acceleration, and we must find the position from the acceleration. And if the initial position started at 5 meters with a velocity of 20 meters per second at t2. So first, we want to find out what s of t is going to equal. So s of t is going to equal the integral of v of t dt. And then vt is going to equal the integral of acceleration of time of dt. So first we want to find the velocity, because we need to find the velocity to find the position. So vt is going to equal, from this equation from above, the integral of of 18t minus 4. And we're going to anti-derive this. So we are going to do t squared, and t is going to have to drop down. So this is going to be 9t, because if you derive this, it'll be 18t, but we're doing the opposite. And this will be 4t plus c from the dt. And we know that, so this is the function over vt. And we're given that when the velocity is at 2, when t equals 2, velocity has to be 20. So what this means is that when v of t, or v of 2, equals 9 2 squared minus 4 plus, times 2, because of the t, plus c, it will equal 20. Now we're going to do some algebra to find what c is. We need to find what c is to find out what c is, so the function equals 20. So we're going to go up here. So we're going to have 9, 4, which is just 36 minus 8 plus c equals 20. So we're going to have c by itself. So c is going to equal 20 plus 8 minus 36. So this is going to be 28 minus 36, which is just going to be c equals -8. And now we're going to plug this into the position over time graph. Our position when the integral of vt. So with this information, we're going to do s of t equals the integral of the equation, but instead of c, we're going to plug in c equals -8. So we're going to have 9 t squared minus 4t plus minus 8 dt. I'm going to clear this up a little bit so we could start from up here. So now that we have this equation, we're going to move over here. So we're going to find the integral of this function, of the integral. So this is going to be, you could put t3 to 3, because when you bring down the 3, it'll be 9, and minus 1 is 2, equaling the 9 t squared minus t squared of 2 because you bring down a 2, it'll be 4, minus 1 will be 4t, as stated below, minus 8t, because it's a constant, plus c. So this is going to be the position of time. But we know that the initial position started at 5. So when you set s to 0, because it's the initial. So when you set time to 0, this is going to be 0 squared, which is going to just be 0, minus 2 times 0 to the power 2, which again is going to be 0, minus 8 times 0, which is just 0, plus c. And we know that s of 0, the initial position, is going to be at 5 meters, stated in the initial position in the statement. So this is going to be 5. So it's going to be c equals 5. So that means that when s of t, the equation of s of t is going to be s to t power 2 minus 2t, cubic squared minus 8t plus 5. And this is going to be your final equation for what the statement is asking for. Find the equation of st if the initial position started at 5 meters.